On this quiz, we will cover the difference between the one-sided and the two-sided alternatives. Also, we will cover power. So when we think about if the alternative is one-sided or two-sided, we need to think about, is it less than, greater than, or does not equals to? So right here we see that a small town requires 3/5 majority to pass a budget. A local newspaper conducts a poll to see if there is evidence it will pass. Once again, evidence goes with the alternative. Since we're looking to see if something will pass, we want to see a one-sided alternative that it'll be greater than. So let's make sure we write this out properly. Now, if you'll notice, it has the null states in all of these that the true proportion, that is what P is, the null states that the true proportion will be equal to 3/5. The alternative will be that the true proportion is greater than, because the alternative is that it will pass. Do we have evidence that it will pass? So right here we see the alternative states that the true proportion is greater than 3/5. As always, be able to write these out. The alternative only shows greater than, less than, or does not equals to. So some of these are just completely wrong. Going on to the next problem right here. A college dining service wants to know if students prefer plastic or metal cutlery. So we don't know which one they would like better. So the true proportion of students who like plastic might be higher. The true proportion of students who like metal might be higher. We don't know. And tell you the truth, I hate those plastic forks. You ever have one of those little dongle things break off? Little pincher things? I don't know. So weird. But anyways, with that in mind, it's a two-sided alternative because they could like plastic more, they could like metal more. We don't know. Going down further, we would assume, and let's think about this, if we talk about the true proportion of students who like plastic, well, the null states that they like them the same. We don't have evidence to suggest that they like one more than the other yet. So we would assume that they like them the same, and we'd want to see evidence that they like them differently. With those words in mind, liking them the same would say the true proportion is equal to 50%, and liking them differently would state that the true proportion is not equal to 50%. Remember, if we're going to claim they like one more than the other, we would claim that they don't like them the same, and we'd need to show evidence of that. We'd need to show evidence that there is a preference. Make sure you can write these out in statistical formatting. P right here is the true proportion. This value over here is P naught. 0.5 is the value we are testing against, P naught. So you could state this, the null states P equals P naught, the alternative states P not equal to P naught, and P naught right here is 0.5. At a small computer company, only 62% of the hard drives processed passed all their performance tests. Management recently invested resources into the production system and now conducts a test to see if it helped. So when we think about things helping, we want more hard drives to pass. So if they're trying to see evidence that it helped, we would assume right here a one-sided alternative because we want to see it helped. And we want to see that the true proportion of hard drives that pass is actually greater now. So the true proportion of hard drives that pass with the null, if nothing has changed, will be equal to 0.62. So there's a lot of right ones. This one's right here. A, E is right, D and F are correct. But we're doing a one-sided alternative. So we never have an equal sign, so that's just nonsense right there. We're down to D, F, and A. This is a two-sided right here, and these are one-sided. We want to see that the true proportion of hard drives that pass is greater than. We want to show evidence of that. We want to show evidence that we have done something to improve the true proportion of hard drives that pass. If we fail to reject the null, well, we'd say, well, looks like we're still stuck at 62%. Make sure to practice this up. I know I've been stressing that a lot, but these are great ways. Test 3 is far from written right now, but these are great ways of testing to see if you can do a null and alternative. We could put in mu in here, which you'll see in later chapters, which is the true mean. We could even put sigma, which we don't do tests on sigma in this class, but that would be the true standard deviation. So there are ways we can trick you up, but look right here, we have the population parameter being tested against some test value. This is the way we write nulls and alternatives. Anytime you do a test, you should write out the null and alternative first for that test, even if the question doesn't ask you to do it. Going right here, a computer company is sued for job discrimination. Only 23% of the newly hired candidates were immigrants, when 35% of all applicants were immigrants. So with this in mind, think about this. In a court case, you are innocent until proven guilty. What do they need proof of? You being guilty. So the alternative would be that you're guilty. You can't just be like, they are guilty, now prove you're not. It's they're innocent, now prove they're guilty. So in the context of this problem, we would reject the null in a type 1 error. And let's write out a simple little chart here to help you understand type 1 and type 2 error. The chart we will use to help you understand type 1 and type 2 error is first we will count 1, 2. Then we will label the sides of the battery, plus, minus. Oops, there we go. And then we will give the letters of the alphabet, A, B. This is our chart for remembering type 1 and type 2 error. Type 1 error is a false positive. It is also associated with alpha. You can just line everything up here. 1, positive, A. So this means when we have a false positive, we've committed a type 1 error. What is a false positive? Well, in the medical industry, a false positive is when they say you have a disease and you don't. So a false positive on a test would say someone has some random disease, and then it turns out they actually don't. And this happens quite often. Strep throat tests come back with false positives. Oftentimes they'll do it by swabbing the mouth, but then they might come back and do a better test. And in this instance, when they swab the mouth, they might get a false negative. A false negative is a type 2 error. What does a type 2 error mean? It means that we said we didn't have results, yet there was actually reason to reject the null. Because when you go to the doctor, they don't say, you're sick and now I'll prove you're not. They say, let's find evidence you're sick. So if we have negative results on the test, we do not have evidence. So they say, you're healthy, but you're actually not. So with this in mind, keep straight what is a type 1 and type 2 error. In a type 1 error, we reject the null, but we were wrong. So the book definition of a type 1 error is rejecting a true null. And we do this by accident. We don't know it. So we reject the null, but we shouldn't have. In a type 2 error, we fail to reject the null because it's negative. Fail to reject. But we should have. We go to the doctor and they say, you don't have strep throat, but it turns out we actually do have strep throat. In a type 1 error, we go to the doctor and they say, oh no, you have strep throat. But it turns out we don't. So let's go back and look at this problem and make sure we answer everything correctly. In a type 1 error, they're going to find that the company is discriminating. They're going to say, we have evidence. Remember, positive results. We have evidence. When in fact, it is not discriminating. Type 1 error. The opposite is a type 2 error. They're going to say, we don't have any evidence that they're discriminating, but in turn, or in actuality, they are discriminating. Going down here, we can see the relationship between alpha and the power of the test. Now, when we increase alpha, we increase type 1 error. But when we increase alpha, we also increase the power of the test. The power of a test is the ability, and this is something great to write down, for a test to correctly reject the false null. The power of a test is the ability for a test to correctly reject the false null. Now, when you think about that, to reject a false null means that we reject when we should. And to do that, we need to reject. So if we increase alpha, we will reject 5% of the time here and 10% of the time here. So in this, and it's very confusing to read, we are not increasing alpha, we are decreasing alpha. It says if the hypothesis is tested at the 5% level instead of the 10% alpha, what we are doing right here is decreasing power. Let's go to decreasing. Because the significance level has decreased. And the wording on here is kind of weird. If the hypothesis is tested at the 5% level instead of the 10%, so have a smaller alpha, the power of the test will decrease. Once again, alpha going up makes the test more powerful because we can reject more often and we'll catch more false nulls. Power going down means less rejections, means a less powerful test. What happens when we do it on, the lawsuit is based on 74 employees, and what would happen if it's based on 177 employees. Now there are three things that control power. This is the second one. Alpha was the first. Sample size has the same relationship. If sample size increases, power increases, because we understand the distribution better. Think about if I went out and sampled 10 people at UT and I found out that maybe 50% of them are smokers. Do you think I have evidence that there's a ton of smokers at UT, or could I have just found a bunch of random smokers? What if I went out and sampled 1,000 people? I would have a better understanding of the true proportion of smokers. So if they only sample 74, they wouldn't have as good of an understanding as 177. That makes this test more powerful here. When sample size increases, power increases. So the power will increase because the sample size, let's see here, is the power of the test higher than, lower than, or the same as if it were based on 177? Let me scroll here. And the power of the test will be lower. Let's look at this. We seem to have things reversed again. The lawsuit is based on hiring 174. Is the power of the test lower than... Wow, they make this so confusing. The only thing that makes sense here at all, what they're saying is, if it were based on 177, what would happen if we based it on 74? And this is a horrible question, so confusing. But the only thing that makes sense here is that the power of the test is lower because the sample size decreases. The power of the test is higher because the sample size decreases does not make sense at all. If sample size increases, power of the test increases. If sample size decreases, power of the test decreases. Finally, the third thing that impacts power is effect size. The effect size is the true difference between the null and the truth. So to think about that, I have one last example. If someone claims to be a 90% free throw shooter, and they're actually a 30% free throw shooter, how quickly on the basketball court would you be able to detect that? They say, I'm a 90% free throw shooter, and you go out and they're missing every shot. Yet that would be pretty easy to detect. The null right there is that they're a 90% free throw shooter. The alternative is that they're less than 90% free throw shooter. And you could find evidence for that alternative pretty quickly, because the effect size is the difference from the null, which is 90%, to the truth, which is 30%. You'll find out pretty quickly that they are not a 90% free throw shooter. But what if they claim to be a 50% free throw shooter, and they're a 30%? You'd eventually find that out. You'd be like, I don't think you're really a 50% free throw shooter. You're not as good as that. But the difference between 50 and 30% is smaller. The null is that they're claiming to be a 50% free throw shooter, and you're trying to show evidence that they are actually less than. So you'd start out saying the true proportion of free throws they make is equal to 50%. Let's show evidence that the true proportion of free throws they make is less than 50%. But considering that the effect size there between the claim, 50%, and the truth, 30%, we would see that it's harder to detect. We would need to increase the sample size. We'd have to have them out on the basketball court a little bit longer to detect this. Good luck, and don't get mixed up on these last few questions. The wording is tricky. Good luck with this assignment.